Hi, my name is Adams. For this assignment, I created an object-oriented Java shipping and logistics system that calculates shipping costs and generates shipping labels. My program demonstrates several concepts, including inheritance, composition, protected members, the super keyword, and the method overriding. The program also uses an interactive menu that allows the user to create multiple shipments until they type done. I'll start with the person class. The class represents either a sender or recipient. Instead of storing addresses information directly inside the shipment classes, I create a separate class that contains the person's name, address, city, state, and zip code. The structure initializes all 5 fields. I also override the toString method to say whenever a person object is printed, the information is automatically formatted as a shipping address. This demonstrates encapsulation because all the person's information is grouped together into one object. Next is a shipment superclass. This class contains everything that every shipment has in common. It stores the sender, the recipient, the package weight, and the base cost per ounce. I declare these variables as protected so that subclasses can access them directly while still maintaining object-oriented design. The constructor initializes all these common attributes. The calculate cost method returns the weight is multiplied by the base cost per ounce, which is the calculation for a standard shipment. I also created a get shipping type method that returns standard by default. Finally, I override toString method so that it prints out formatted shipping label, including the sender's information, recipient information, shipping type, and total shipping cost. Instead of writing separate classes with duplicate code, I use inheritance to write standard shipment, 2-day shipment, overnight shipment, all extend the shipment superclass. This means that they automatically inherit the sender, recipient, weight, base cost, and toString behavior without rewriting everything. Inheritance reduces duplicate code and makes the project easier to maintain. The standard shipment class is the simplest class. Its constructor simply calls super sender, recipient, weight, base cost, which invokes a superclass constructor and initializes the inherited variables. It only overrides get shipping type so that the shipping label displays standard. The 2-day shipment class adds one additional attribute, the flat expedited fee. The constructor calls super. First, it initializes all inherited data and then initializes the flat fee. I override calculate cost. Instead of just multiplying weight by cost, I use super calculate cost plus flat fee, which reuses the superclass calculation and then adds the expedited processing fee. This demonstrates proper use of super keyword to access inherited methods. I also override get shipping type to display 2-day. The overnight shipping class works similarly. Instead of flat fee, it stores an additional fee per ounce. Its calculate cost method computes weight times the sum of the base cost per ounce and the overnight premium per ounce. This produces a higher shipping cost for the overnight deliveries. Like the other superclass, it overrides get shipping type so the label correctly displays overnight. This project also demonstrates composition. A shipment does not inherit from person. Instead, a shipment has a sender and a recipient. Both of those are person objects. Using composition keeps the design modular and reusable. If I ever wanted to just change the way the addresses are stored, I would only need to update the person class instead of every shipment class. Now it's time for the driver class, which is the shipping app class. It contains a method. The program starts by displaying a menu that asks the user to choose 1 for standard, 2 for 2-day, 3 for overnight, or type done to exit. If the user enters done, the program prints a goodbye message and terminates. Otherwise, the program collects sender information, recipient information, package weight, and base cost. Depending on the user's selection, it creates either a standard shipment, a 2-day shipping, or overnight shipment, which could differentiate in price. This demonstrates polymorphism because I store each object and the shipment reference while allowing each subclass to execute its own version of the calculate cost. After the object is created, the program prints the shipping label by simply printing the shipment object, which automatically calls the overridden toString method. The loop then repeats until the user enters done. Now let me run the code for you. I'm just typing in